Continuing to lesson 10.2, explicit formulas. We're dealing with sequences in this chapter and some other things after that, but we have explicit formulas here. So what is an explicit formula? We've already talked about recursive formulas, and a recursive formula uses the term or terms before it to tell us what the term we are on is. But an explicit formula is a formula that calculates the nth term, a sub n, just using n, well, not just n, and some other things, and not using the previous terms. So it tells us explicitly, outrightly, what the term is. So here we have a sequence, 1, 4, 7, 10, 13. It looks like we keep adding 3. So right here is the recursive formula, which we talked about in the first lesson. The explicit formula, however, is a sub n equals 3n minus 2. 3n minus 2. And so we could plug in. So it says check the formula. Does this actually work? I'm telling you it works, but let's check it to make sure. So our first term, a sub 1, we put 1 in for n. So 3 times 1 minus 2 is 1. Well, that worked. The second term, we plug in 2 for n. So 3 times 2. So again, we're just plugging it in this formula. Three times 2 minus 2 is 6 minus 2 is 4. Check. 3 times 3, so we put in 3 for n. 3 times 3 minus 2. 9 minus 2 is 7. That works. And there we have it. And for some reason I have the 300th term there. You can find any term you want. The 300th term, you plug in 300. 3 times 300 is 900 minus 2 is 898. So it does give us our terms. Something to notice here, this goes up by 3. Where do you see that 3 in our formula? Well, it is that number right there that's multiplied times n. Here we have another one. Find the first 5 terms of a sub n equals 2n cubed minus 10. I'm going to write that just in one line here. 2 times n cubed minus 10. A sub 1. We plug in a 1. Make sure we do the order of operations. 1 cubed is 1 times 2 is 2, and 2 minus 10 is negative 8. To find the second term, unlike recursive formulas, we don't need this negative 8. To find the second term, we just put 2 in for n into our formula. 2 cubed is 8 times 2 is 16. 16 minus 10 is 6. To find the third term, we're going to put 3 into our formula. 3 cubed is 27 times 2 is 54 minus 10 is 44. Our fourth term, we want to put 4 in for n. 4 cubed is 64 times 2 is 128 minus 10 is 118. And finally, for this one, the fifth term is 5 cubed. Put 5 in, and you have 5 cubed. So 5 cubed is 125. 125 times 2 is 250, minus 10 is 240. So find the first 5 terms and write them in a list. This was the formula. So the first 5 terms, negative 8, 6, 44, 118, and 240. There they are in a list. Remember, a sequence is a function. So remember, this is paired with 1, so this is like the point where the term 1, negative 8, 2, 6, 3, 44. You don't need to put that for your answer. I'm just reminding you that they do have a domain value and a range value. All right. 3n minus 2 is the explicit formula for a sequence. Find the recursive formula. a sub 1. So what I'm going to do is I'm going to find the first few terms and see if I can use that to help us find a recursive formula. So plugging in 1. 3 times 1 minus 2 is 1. Our second term, 3 times 2 minus 2. That's 6 minus 2 is 4. A sub 3. We're going to put 3 in for n. That's 9 minus 2, which is 7. Put in 4. That's 12 minus 2, which is 10. All right, I'll do the first 5 terms here. Put in 5. 15 minus 2 is 13. And then we want to look at our sequence and see if we notice anything to help us put it in a recursive formula. So it goes 1, 4, 7, 10. It looks like we're just adding 3 each time. So our recursive formula, to get our term that we want, we take the term before it. So we did this last class, a sub n minus 1. Make sure that n minus 1 is all in the subscript, and we add 3 to it. But remember, to write a recursive formula, we need to define the first term. So our first term was 1. And yes, I do realize this is the exact same formula that we did a few examples ago in this lesson. So I didn't mention this thing right here. Not all sequences have explicit formulas, but any sequence that has an explicit formula also has a recursive formula. All right. Find the explicit formula for this sequence and then find the 10th term. Well, first let's observe, look at this formula. We have 1 plus root 2, 4 plus root 2, 9 plus root 2, 16 plus root 2. All right, so it looks like to find the nth term, we definitely want to add plus root 2. But what are these numbers? What's 1, 4, 9, 16? Hopefully you recognize those as perfect squares. So for our first term, we would want to take 1 squared plus root 2, 2 squared plus root 2, 3 squared plus root 2. So it looks like we want n squared plus root 2, which means our 10th term, because we're supposed to find a sub 10, would be 10 squared plus root 2. Our 10th term is 100 plus the square root of 2. All right, find the explicit formula for 17, 20, 23, 26, 29, 32. We want an explicit formula. Well, our first term is 17. Our second term is 20. So it looks like we're adding 3. And so when we add 3 to each term, that is going to help us. It's going to be an important part of this. So we can try a few things, or we could try a few things, and you might do some guessing and checking. We're adding 3, adding 3. So really, to get to our 4th term, we needed to add 3 times. So we use 3 often, so it seems like we're going to multiply something by 3. I know this is our first term, but if there were a 0th term, which there's not, what would it be? It would be 14. So to get to our next term, this would be 14 plus 3. But then that would be our first term is 17. Our second term would be 14. It would be our first term, 14 plus 3, plus another 3. Next would be this term plus another 3. So it looks like our nth term, we would take 14 and add on n threes, so 3n. Now this actually looks kind of linear, so we would do 3n plus 14. And I mentioned before, and we will study this more later, if you keep adding 3, which is arithmetic, its equation will look like a line. Be a linear equation. But we'll have more of that later. So here are the formulas that we talked about before for sequences, the different sequences we talked about before. We had arithmetic, geometric, factorial, harmonic, and Fibonacci. Not in the same order, actually, but here we have our different formulas. We've already talked about these. And then we will talk about these, especially, again, the first two, arithmetic and geometric, are the ones that occur more often that we'll talk about more. We'll talk about those formulas. Factorial, that's when we keep multiplying. So this exclamation point, if I had 6 exclamation point, it doesn't just mean 6. It just means 6 times 5 times 4 times 3 times 2 times 1. Harmonic, there it is. Harmonic, actually, if you notice, this looks a lot like this formula because harmonic has an arithmetic sequence in the denominators, and this one is just a very interesting formula that we won't use very much, but that is the formula for the Fibonacci sequence.